All right, chapter 5, section 1, angles of triangles. Like I said, you guys have seen these words that you're going to see in the notes. You've seen them over the years in middle school, hopefully. But it's not a difficult lesson. It's, again, vocabulary and kind of review. The first slide is more like a review for you guys because you've seen this before. So, triangles, what do we know? 3 segments joining 3 non-collinear points. Okay, 3 segments joining 3 non-collinear points. So looking at it, that's what makes up a triangle, 3 segments. Points where the segments meet are called your vertices. So I'm going to go ahead and highlight the vertices for you so you know where they're found. So this is a vertice or vertex. This is a vertex. This is a vertex. Okay, and those are called vertices. I have 3 vertices. Sides are segments. Each side of my triangle is considered a segment. Why is it a segment? Because they have endpoints. They stop at a specific place. When you are naming a triangle, looking at this that I'm highlighting in yellow, there is a triangle symbol in front of it. That is how I'm naming this triangle. It is called triangle ABC. So normally that symbol is showing me what we're looking at. So this is triangle ABC. Vertices, like I said, we've covered vertices before. We should know what our vertices are. A, B, and C are my vertices. Sides, because they're segments, they do not have the arrows on top. So I have side AB, I have side BC, and I have side CA. And then angles, going back to chapter 1, I have 3 angles. Angle A, angle B, and angle C. Any questions on that? Again, information that you guys have learned already, kind of just a review. All right, words that we've heard multiple times over and over again. Scalene, isosceles, equilateral, stuff that we have seen already. So the difference between these, one, I have my scalene. What is scalene? Scalene is when no sides are the same measure. So they're all different. No congruent side measures. Keep in mind that it has to do with the sides, not the angles. These are the side measures, not angle measures. Isosceles, again, a word we've heard before. 2 sides that are the same. So looking at this diagram, I have my 2 congruent marks. And then equilateral, lateral meaning lines or sides if you want to think of it that way. I have all sides are the same. So again, using my congruent marks, each of these are going to be the same measure. So that's the difference between classification by sides. All right, classification by angles, again, words we've seen before. I have acute, which means all angles are less than 90 degrees. All of them are less than 90 degrees. I have obtuse. Keep in mind, with obtuse, you only need 1 angle that is greater than 90. Only 1. So looking at this diagram, this is my 1 angle that's larger than 90 degrees, and it only has to be 1. My right triangle, again with right, you only need 1 angle that is 90 degrees. And then for my last one, I have equiangular, has the word angle in it, so I know I'm talking about my angles. And all angles are going to be equal. If all of my angles in my triangle are equal, can someone tell me what is the measure of those angles? Well, first, do we know the measure of the interior of a triangle? What is the measure of an interior of a triangle? Any ideas? What is the measure of an interior? Katya? It's 180. So any triangle, looking at all these triangles, this is 180. The measure of this inside is 180. The measure of this inside is 180. The measure of this inside is 180. So if all my angles are equal, what should each angle equal? For my equiangular triangle, what should all the interior angles equal? 60. This is going to be 60 degrees always. This is going to be 60 degrees, and this is also going to be 60 degrees. So 60, 60, 60 gives me 180 degrees. So anytime you see an equiangular triangle, all your angles have to be 60 degrees. Triangle sum theorem, we kind of just stated this last slide. The sum of the measure of the interior angles, okay, keep in mind we're talking about the interior angles of a triangle is 180 degrees no matter what. So if I were to add the measure of angle the measure of angle A plus the measure of angle B plus the measure of angle C, if I add whatever angles those are, it's going to give me a total of 180 always. It has to equal 180. So if you're checking your work and you add all the angles and it equals 181, you did something wrong, so go back and check. It has to equal 180 degrees always. Exterior angle theorem. Please understand what this is saying because you will see these questions a lot in the future. The measure of an exterior angle. So I'm going to highlight which exterior angle we're talking about. The measure of an exterior angle, which is right here, my angle 1, of a triangle equals the sum of the measures of the two remote interior angles. Those are my non-adjacent angles. Which angles are we talking about? This is talking about angle B and angle A. So if I were to add angle A and angle B, that's going to give me the measure of my exterior angle. So if I were to add these, it's going to give me the measure of angle 1. So I'm going to go ahead and give you an example. So I'm going to draw it right here. It's going to look like this. Keep in mind the arrow could be on any side of my triangle. So if I'm looking at this one and I were to go ahead and draw it, let's say that this was 60 degrees and this was 40 degrees. What's the measure of A? Yes. Good, so I'm going to add these two together and that's going to give me 100 degrees. Let me just go ahead and give you another example. Let's say they were asking for up here, this angle right here. Let's call it B. And if this is 100, okay, so I'm going to kind of draw it. If this is 100 and this is a straight line, what's this angle measure right here? What is it? Good. This has to be 80 degrees. This angle right here is going to be 80 degrees. So I drew my little 80 right there. It's kind of small. Sorry about that. So how would I find the measure of angle B? What do I have to add? Which two angles do I have to add? Which two angles am I going to add to get B? Remember, it's the non-adjacent interior. Which ones? Not 60 and 40. 60 and 80. So I'm going to add 60 and 80. What's 60 plus 80? Good. This is going to be 140 degrees, okay? So if you add these two angles, it's going to give you that exterior angle. Or, like I did before, you could look at this. If this is a straight line and I have 40 degrees here, subtract from 180 and you get B. Okay, but you guys have to know, because sometimes they will not be giving you this measure right here. If this measure was not given, you have to understand that by adding that 60 and 80, that's going to give me my 140, okay? So it doesn't matter which side they're giving you, just know when you add the two non-adjacent interior angles, it gives you the exterior angle. So that's just something for you to understand. Okay, questions on exterior angle theorem? Okay. All right, corollary. A corollary to a theorem. A statement that can be proved easily using the theorem. That's fine, but I just need you to look at the second one. Corollary to the triangle sum theorem. So pay attention to what's saying. It says the acute angles of a right triangle. So looking at this right triangle down here, my acute angles are going to be A and B. Those acute angles are complementary. What did complementary mean? What does complementary mean? Adding two angles to equal 90 degrees. Complementary is 90 degrees. So please pay attention to this one. If I'm adding both angle A, the measure of angle A, plus the measure of angle B, it will always equal 90 degrees. Keep in mind, understanding what this means. If this is a right triangle and this is already 90 degrees, remember, your triangle equals 180 degrees. So if they're already giving me 90 out of the 180, these two angles have to equal 90 degrees. Why? Because 90 plus 90 equals 180. So anytime you see a triangle, I've always seen this multiple times in tests and quizzes. What students normally do is they add all of these if they're just finding one angle. You don't have to add all three. All you have to do is take the angle that's given and subtract it from 90. So I'm going to go ahead and just give you an example. So here is a triangle. Let's draw like this. Let's say that this is 90 degrees right here. If this was 40 degrees, do I really need to add 40 plus 90 to subtract 180? No, I don't. Because we should know these two angles added together is going to equal 90 degrees. So if I add them together and it equals 90, how would I figure out x? Well, what I just subtracted by? I only have to subtract it from one number, 90. All I have to do is 90 minus 40. What would I get left over? So x would equal 50 degrees. I don't have to add them together, 40 and 90, and then subtract by 180. I don't have to do that. I just have to take that 140 degrees, subtract it from 90 degrees, and that's going to give me my remaining x. So understand that when you see a right triangle, the two acute angles are going to be 90. Keep in mind, they have to be acute. If you're adding them or subtracting them and you get something that's not acute, you did it incorrectly, so you need to go back. All right, looking at these examples. Example number 1, it says state whether the triangle with the two angles have the given measure is acute, right, or obtuse. So a couple ways you can do this. You could add these two and figure out what they add to, and then you could determine if it's acute, right, or obtuse. Or you could actually find the third angle. So I'm going to go ahead and do the first two. So adding them, I have 55 plus 43. I'm going to get 98. If 2 out of my 3 angles are 98, what kind of triangle do you think this is going to be? Yes. Not obtuse, because remember, I did not find the third angle. I'm just kind of figuring out if I were to draw this. This would be 55, this would be 43. That added together is 98. If I want to figure out that third angle, I would have to do 180 minus 98. What's 180 minus 98? Okay, so if my third angle is 82, is that acute, obtuse, or right? Acute, they're all smaller than 90 degrees, so this is acute. So when I say you can add the two angles, keep in mind if I add the two angles and it's more than 90 degrees, if these two angles are more than 90 degrees, that means this one should be less than 90 degrees. Does that make sense? So that's how I'm saying that it's acute without having to subtract. So looking at B, I'll go ahead and do B over here. If I were to add 47 plus 43, what would I get? 90. So what kind of triangle is this? Right, I don't even have to do the work for the third angle, but we should know what the third angle is. What would my third angle be? What would my third angle for B equal? 90. 90 and 90 is 180. And right off the bat, I know that this is going to be a right triangle because whenever you have 90 degrees, it's a right triangle automatically. So go ahead and do the next 3 on your own. You can find the third angle, but you don't have to find the third angle, but I will go ahead and solve for the third angle. So go ahead and try these and tell me whether it's acute, right, or obtuse. All right, hopefully we finished. Go ahead and checking these. For C, I will go ahead and just write them out. For C, if I were to add 80 plus 75, what would I get? 155. So think about it. If 2 out of my 3 angles already equal 155, what would my third angle be? Would it be smaller than 90 or larger than 90? It would have to be smaller than 90. If you did it correctly, it should have been 25. All these angles are smaller than 90, so this should have been acute. Okay. Looking at D, I have 33 plus 33. What is that going to give me? 66. Is that smaller or larger than 90? Smaller than 90, right? So that means my third angle, would it have to be smaller or larger than 90? Larger than 90. So if you did the work correctly, that should have been 114. Making this what kind of triangle? Obtuse. And then my last one, E, if I add 24 plus 66, what would that equal? 90, making my third angle 90 degrees because 90 and 90 is 180. This would be a right triangle. Keep in mind for obtuse and right, you only have to have one angle that's obtuse for obtuse, and you only have to have one angle that's 90 degrees. Acute, they all have to be smaller than 90. So please be aware of that. Do you guys understand that why I'm only adding 2? That's going to give me the information to figure out my third one, but if you have to, for all means, subtract it from 180 instead of guessing if you're unsure. So take that 155, 180, that's going to give you 25. So do the work if you have to. Don't just estimate if you're not sure on how to estimate it. All right, example number 2, find the measure of angle A. Looking at A, looking at the first A, we have what we know as vertical angles. What do we know about vertical angles? Vertical angles are what? They're congruent. Okay, they're opposite, yes, and they're also congruent. So these angles right here are congruent. So if these angles are the same, and then looking at, I have 2 triangles, one here, one here. These angles are the same. This is also 50. What should my missing angle A be? Good, 80 degrees. So this right here is just 80 degrees. All right, looking at B. Looking at my symbols, I have a congruent symbol, a congruent symbol. These are both 40, so what should be angle A? Good, 60. These are definitely on the easier side. C, I don't think I have to explain this one. What should angle A be? Good, 110. These are definitely on the easier side. Or you could have done the work. Okay, doing the work, if you add these two, figure out that this was 50, this was 50. 50 plus 50 is 100, and you get 80 left over. Same thing with these, but we should know what's congruent. All right, looking at the last slide, find the measure of angle A. So for D, how would I solve for angle A? How would I set this up? Go ahead, Michaela. Good. So remember, if you add these 2 angles right here, they equal the outside angle. So we're going to kind of work backwards. 180, I'm sorry, not 180, 120 minus 80, what is that going to give me? Good, 40 degrees. So let's say this is 40 degrees. I'm going to go ahead and check my work. I'm going to add these two. 40 plus 80, does that give me 120? Yes, so I did my work correctly. So my answer would be the measure of angle A equals 40 degrees. All right, and E, this is kind of like a word problem. It says in triangle EFG, the measure of angle G is 100 and the measure of angle FEH is 3 times the measure of angle F. Find the measure of angle F. So looking at this one, highlighting and filling in, they're telling me the measure of angle G is 100 degrees. Then they're telling me that the measure of angle FEH, so here's F, here's E, here's H, is 3 times the measure of angle F. Do I know what the measure of angle F is? No, so I'm going to represent it as X. How would I set this up to solve? How would I set this up as an equation to solve it? Any ideas? How would I set this up to solve? I'm writing an equation, so it has to have an equal sign in it. Any ideas for this one? Okay, if I add these two interior, they should equal my exterior. So I'm setting it up as 100 plus x equals 3x. And then I'm just solving for my x. This is a regular algebraic equation. Subtract x from both sides. We get 100 equals 2x. Divide both sides by 2. X equals 50 degrees. Let's go ahead and check my work. If I solved it correctly, we said this was 100. If I plug in 50 here, I have 3 times 50, which gives me 150. If I add 150 and 50, does that give me 150 degrees? Yes, so I know my answer is correct. X equals 50 and I'm done. Homework is on big ideas. You do not have to show work for 1, 2, and 3. Everything else you have to show work for.